Good evening, friends. As we have learned in a previous video about the closure concepts in Java, as we can see that this is our closure, our lambda expression, and here it is referring to a variable which is defined outside this closure or outside this lambda function, which is string of name of John. Now this will not compile because we are accessing a variable name here, which is outside this lambda and which is also not final or effectively final. It is not final because we are not declaring it as final string name. And also it is not effectively final because name has been changed here from John to Betty. That's why this code will not compile. So this is the closure concept as we have discussed previously in our previous video. Now let's extend this concept, this closure concept in Spark. So in Spark also, we have got a similar concept that whatever the variables which we have declared in the driver program, whenever we call any function, any map or reduce function or the transformation function, so that function would be will be working as a closure and which will be copied over all the variables which are declared in the driver program, that will be copied over to all the executors. As we have learned previously that as per the basic Spark diagram, we have got a driver program where we where we create our Spark context, we create the RDDs, and all those RDDs are spread across all the worker nodes. And all these worker nodes are separate individual entities, which will be having its own executor, its own set of tasks, and a cache to work on. And this is all done via cluster manager. If we go further deep dive into the details, which we have already discussed in our previous videos, that whenever the driver program where we create the Spark session and the Spark context, after that, once we create an RDD, and whenever any action is called, once this action is called, the Spark context will create the jobs. And the jobs, it will create the RDDs and it will have the set of tasks to be done. For example, whatever we are doing, like for example, map, filter, and all, because it's all lazy evaluation. Whenever any action is called, only then the previous filter and maps are being called. And all these tasks are done, and then all the tasks are launched via cluster manager. And cluster manager is the one which is talking to all the worker nodes here, and all the tasks are distributed across it. So whatever the variables, for example, in our example here, if we are using this, let's take this example. We have created a list of 10 integers, and then we create an RDD. This is all done in the driver program by using the sparkContext.parallelize. We get our RDD. And this is our shared variable, which is declared in the driver program. Once we call this for each method, where we are trying to accumulate all the sum, and then finally print the total sum in the driver program again. This code will not compile for a couple of reasons. First reason is that this sum, this is not final or effectively final. That's why it will not compile. And at the background, what is happening is that whenever the RDDs are created and the tasks are distributed across all the cluster nodes, in that case, all the variables which are declared, for example, sum here, it would be serialized and sent to each executor. Our closure here is the for each function. So this closure for each function, it will try to serialize everything, and whatever the variables which has been accessed from the sum, like here we have got sum, this would be serialized and send a copy of this sum variable across all the cluster nodes. And now, whenever we want to refer back, or whatever the computation that we are doing here, for example, we are summing it out. So in the driver program, although there would be in the memory location, it would be having a default value of sum as 0 before the serialization. But whatever the manipulations that we have done at each executor node, that will not be propagated back to the driver. So the driver program will be still showing as sum. So this statement, this will be still showing as 0, even though this function will not compile first of all. Even if you make it compile by some way, which we'll discuss later, still the sum would be coming as 0, just the pre-serialized version of the sum variable. So there is, as mentioned, that the final value of sum will still be 0, since all operations on sum were referencing the value within the serialized closure. Although there is an exception to it, that in local mode, because I've got my laptop open and I'm using my local mode while running all these test cases. In local mode, in some circumstances, the for each function will actually execute within the same JVM as the driver, and executors will reference the same original sum and may actually update it. But this is just based on our top example that we are using the local mode, because it's the same JVM and there are no separate executor nodes, and it might be running on the same JVM as the driver. So for having to achieve this, what is the solution for this? So there is a concept of accumulators in Spark that we will be discussed in details later. But accumulators are the similar in Spark that it's actually provide a mechanism to safely updating a variable. For example, here in sum, we are trying to accumulate something. So that's why this accumulator would be able to update a variable when it's split up across worker nodes as a cluster. So in general, I mean, we will discuss very much in details about this accumulators and also the broadcast variables later on. So as written in this test case that we have created, we have got data list of 10 integers. Then we create our RDD using the sparkContext.parallelize method on this list. And this is our shared variable to be spread. If I try to uncomment this, it will show that it will not compile here. Because if I just hover over it, it will show me that the variable should be final or effectively final. Because we are mutating this sum variable inside this for each closure, it is trying to manipulate this. Okay, so that's what we are trying to explain, that the closure concept will not work if we are not using the special type of shared variables such as broadcast variables and accumulator variables. Let me comment it out again. So let's go back. So in general, what we have learned from this exercise is that closures in Java and closure in Spark are quite similar. That whatever the variables that we are trying to share inside the closure or inside the lambda function in Java, that should be final or effectively final. But in Spark, the concept is further extended that we should not try to construct like loops, for example, for each that we have used, or some locally defined methods in the driver program, which are serialized and spread across all the executors to execute the task. That should not be tried to mutate some global state. Here we're trying to mutate some global state. Here is the sum variable. So now let's extend our concept about this closure for the shared variables. So as we have learned that all the global state, in our case, it was sum variable. So whenever we actually call any Spark operation such as map or reduce, so this sum variable would be serialized first, and then the copy of this would be sent to all the executor nodes, all the remote machines, and whatever the updates that we are doing on that variable, that will not be propagated back to the driver program. So we consider this diagram again. So the sum variable, which is here, it will be serialized, and then the copy of that serialized version would be sent across all the worker nodes. And whatever the action that we are taking in each of the worker node executors, that will not be propagated back to the driver program. So that's why it will always be the pre-serialized version of 0, default value of 0. So because these variables are copied to each machine and no updates to the variables would be sent back. However, Spark has got two limited types of shared variables for our common usage patterns. One is the broadcast variables and another one is accumulators. For our case, for example, here the sum variable where we are accumulating the stuff. So for that we have got accumulator. So these variables are used to aggregate the information through associative and commutative operations. And otherwise, we can also use as a broadcast variables. And these variables are used to save the copy of data across all nodes. So this is exactly what we are going to refer, that whenever we want to use the shared variables concept in Spark, instead of using the generalized like closure type of concept as we use in Java, the same cannot be used in Spark. It will not give the expected results. Instead of that, we should try to use broadcast variables and accumulators. So let's discuss about broadcast variables in more detail in the next video. So see you all in the next video.